Thank you for having me today. Good morning. I lead a set of developers at Upwork, and we have a set of services we run. I want to talk to you today about MongoDB using NoSQL, how it differs from relational databases, some of the problems we ran into, and how Percona has come in and helped us restructure our databases. So we run on AWS. We have mostly Postgres databases. So it's really great to hear that they're supporting Postgres now because we use them for MongoDB support. But the one I want to talk about today is the MongoDB application. So we have a chat application where the freelancers can talk to our clients. Upwork is a site where we're kind of like a monster for freelancers. So if you want to find a freelancer in engineering, technical writing, doesn't matter, lawyers, nurses, whatever. You can go to our site, you can search for freelancers all over the globe, and we can line up clients and freelancers and get you guys talking to each other. So we actually hire a lot of our developers. I have 6 developers. They're all freelancers. They're all overseas. None of them are in our time zone. They all work when I'm asleep. And we use Postgres for like 95% of our stuff because we can use it for small databases. But when you need to scale, when you need to get big, we use MongoDB. So we use MongoDB we have a chat application very similar to Slack. And we started this thing in 2014. We needed it for our freelancers and our clients to talk to each other. We thought about using, maybe outsourcing this stuff to Slack or someplace like that. Maybe we can use their tool and we could go and put our stuff in there. The problem was that we have a lot of logic and stuff built into our chat application. And we have other things that are built into. We have audio and video in there. We have the ability to post informational messages to the group. We have ability to have bots on there so you can talk to it and you can have a bot respond. So there's a bunch of stuff we built in that we decided to do it ourselves. Now I heard yesterday, the Slack guys were up here and they were using MySQL sharding. Now I didn't even know MySQL sharded until yesterday. So that's one thing I learned here. We decided early on to use a NoSQL database and we picked MongoDB about 4 years ago. So we've been using it for a while. We were probably one of the early adopters of MongoDB. And at the time, MongoDB wasn't in as great a shape it is now. It had locking problems. It would lock at the collection level, and things weren't that efficient. So it's gotten better through time. About 2 years ago, we had Percona come in. We were using MongoDB for support before. We weren't too happy with them. We switched over to Percona. We've been very happy with them. They came to our site, and for about a week, Alexander Rubin came in. We sat around for a week. We decided the way we set things up is wrong. And we've been trying to recover from that for the last couple years. So when you set up things wrong in these large databases, sometimes it takes a long time to get back to where you want to be. And so we're still recovering from that, and I'll talk about that today, about some of the problems we ran into, how you program your code differently on a NoSQL engine than you do versus relational databases, and some of the things I like and don't like about both of them. All right. Okay, so we are the largest freelancing site for connecting freelancers with clients. And, So we're the largest freelancer for connecting freelancers with clients. We do approximately about $1.5 billion is done per year through Upwork. And about 1/3 of the Fortune 500 companies use our site. We're based here in Mountain View. We're right down the street. That's our headquarters. We also have an office in San Francisco where most of our product and marketing people are. And we also have an office, about 2 years ago, we opened an office in Chicago, and all the salespeople are there. So that office went from 0 to about 60 or 80 people in about 2 years. So we have about 375 employees and 700 freelancers. So again, if you try to hire engineers in Silicon Valley, it's very difficult. We are based in Mountain View, and we try to get engineers hired. They all go to Google or LinkedIn or Netflix or Facebook or someplace like that, right? They don't want to come to a medium-sized company in the Valley, even though we have all the perks. We have free food and we get unlimited vacation time, all that kind of same stuff. It's hard for us to find good people. So what we've decided to do, we go overseas, we find them overseas because there's good engineers all over the world. And the advantage of this is they don't have to pay them as much. They can stay at home. They can live with their family there. They don't have to move to the United States. And they actually cover us, like when the systems go down at night, they're awake, I'm asleep, right? So I come in the morning, the systems go down when they're asleep, I'm awake. So we get this overlapping structure too. So it's worked out really great. That being said, if you go and use our site to go find people, you still have to interview them, okay? So I interview I probably do 25 interviews before I select somebody. We're very picky. On my team, I only want senior developers. I don't want junior ones. The problem is the junior ones, you can't hand them something and they don't get it done. You need a lot of hand-holding. I don't have time for that. And I don't want to rewrite their code and stuff. So we only look for the senior guys. We're very picky about the developers we hire. I do a lot of my interviewing through our chat application. So I've actually interviewed 4 at a time before. So we'll post a job and everybody will apply. And because most of the people drop out like the first couple minutes. Finding good engineers is very tough. And then it gets kind of depressing because you're going through all these engineers and you can't find developers. And then like in the 25th one, you nail somebody that just nails everything. They hit all the questions correct. And it's fantastic. And that's the people we hire. So we've been trying to actually on our site eliminate some of the people that aren't as good. So we actually require you now to take some tests before you can actually become a freelancer on the site. And we also have some services. We have talent services where you can use our product to actually have pre-screen some people if you want to do that. So we actually eat our own dog food. We hire, most of our engineers are overseas. We got a lot of people from Russia. I have 2 guys from Russia and 1 from Ukraine. I got 1 guy from India, another guy's in Armenia, and I have some QA guys. There's 2 QA guys in India, another guy's in Chile. So they're all over the planet. There's another group that has a bunch of Argentinian programmers. So we hire them all over the world, and we find really good people. Okay, so I talked about this. We used MongoDB. It was interesting to see that Slack had picked this sharded MySQL. And what I'm seeing this week, there's a few things I learned this week. One of them was that MySQL does sharding. I didn't know that until this week. And the other thing I also learned this week was that MongoDB in version 4.0 wants to support transactions. So this is what you're seeing is these companies are looking over the fence at the other company and they're saying, we need to have that product too. We need to have ACID, or we need to have scalability across nodes. And you're seeing people putting this stuff in, and we're all winning by using these products, by doing this. We have we call these rooms. These are channels on Slack. We call them rooms. And we have we call stories the messages that you would put on Slack. We get millions of these per day. We store them in Mongo. We don't really need ACID for this. We're not Wells Fargo Bank. If things get out of whack a little bit, that's okay. So we use Mongo. And I think that's been a correct choice. The scalability of Mongo is very, very high. We only have 4 nodes, but we can scale to many, many nodes. Okay, so we could actually do much more traffic than we have currently today, but we haven't needed it. So I don't regret really picking Mongo, but it's been a good choice so far. Okay, so why would you pick a NoSQL database? Well, there's this CAP theorem that I think most people know about. So what happened was everybody was doing relational databases. Everybody needed ACID, right? And one day some guy decided, you know what we're going to do? We're going to get rid of ACID. And people thought he was crazy. So they basically, by getting rid of ACID, what you can do is you can scale this stuff across many nodes. And for most of the problems you have, unless you need transactions for banking or something like that, you're doing a checkout on Amazon, then you're not going to need ACID. You can just use NoSQL databases. So this is one of the questions I ask when I'm interviewing people. I ask them, how would you design a shopping cart for Amazon? And if you told me, well, I just run MySQL or a Postgres database on a machine, and I'd run the shopping cart for Amazon, I don't think it's going to fly. Okay? One machine running Postgres or MySQL is not going to run Amazon shopping cart. But if you use a scalable server, like a MongoDB, maybe it's possible. I don't know how Amazon runs their shopping cart, and if anybody here from Amazon works on that, let me know, because I'm kind of curious. But what you need to do is you need this scale while they're shopping, and then when you go finally check out, that's when you need the ACID, right? You need to check out using a relational database at the checkout time. So I don't know how they do it, but I want the person thinking about how can you scale databases? How do you need it all the time? What do you need in a database when you're using a database? So one of the reasons we picked MongoDB was we looked at, this is a few years ago, so we looked at Cassandra, and I'd heard that it was hard to administer, and there was a lot of stuff in it that I thought was hard to use. And so we said, no, let's not use that one. MongoDB was quite popular. We looked at Couchbase. Couchbase is similar to Mongo. You can write to multiple nodes at a time, which we don't really need, but you can do that. and it was tied to Memcached, and we use Redis for everything. So what we do with Redis is we use it like a front-end cache. So if you look at a messaging system like a Slack or one of the ones we're writing, most of the data that people are interested in is the last day or last week, right? And all the stuff, the other stuff kind of fades off in the distance, right? So they're not really interested in that. Unless they do a search, they're not looking at that old data anyways. So what we do is we store the last 24 hours of all the messages that are currently active in the cache. We store it in Redis. So we're basically using the write-through cache. When you go and query to fill up the page, we're getting it from memory. We're not getting it from the database. So that's pretty quick. The other thing was Mongo had very good NoSQL support. So it was very popular at the time. The three big ones were Cassandra, MongoDB, and Couchbase. I think that's true today also. And we just picked MongoDB, and we've been happy with it and had no problems with it. The one things I liked about the NoSQL databases was we have this problem where you have an object model in your system. So you're running Java. We have an object model. We're using object-oriented programming. And then you store all your stuff in a relational database, right? And relational databases are basically tables. And they look like invoices. And they look like invoices because they came from invoices, right? So originally when databases were first created, you had items, I want 10 of these at this cost, and I got, and you list that down. And then you have a user table, and there's this guy's address, and he's associated with these orders, whatever. And so you have these pointers going from the users to which orders they have, and you do those pointers through joins, right? So this is kind of an impedance mismatch. And what you have is you map these things down from an object model into a relational model, and you use these really ugly libraries like Hibernate and EJBs to do this. I don't really like this that much. And if you use something like a NoSQL system, there's a much more direct mapping. You can have composite objects in a NoSQL system. I can store the list of all his orders in the guy's name or whatever. If I'm using something like, let's say I'm on Facebook, and you have a Facebook post and all the comments are in there, they would all be stored in the same document. All the comments would go in the same document as the post, okay? So when you go and do the query, it goes and filters all whatever comments you want from that post, gives you the post and all the comments that you would want. So the model maps better to an object model that I kind of liked better, and that's true today. You still need to use indices. You still need to use, you still need to do joins. You can do a join by grabbing an ID and then querying. You have to go across the wire to the client and then query again. But the NoSQL databases are pretty quick. All right, so what do we do right? So when you write your code for a NoSQL database, you need to write it defensively. So you may get data that's bad. You may get data that's bad because you did a schema change and the old records don't have that. It could be there's a race condition or something. Maybe a server that you're trying to fill in data from didn't reply. So we use a microservice architecture. Maybe that REST service that you called didn't reply. The data didn't completely filled in, but you wrote it to disk anyways. So we write our code so it understands if data is bad, how to recover from that. So that's one of the things you need to do when you write NoSQL systems. You also need to run batch jobs occasionally that go through and clean up the data if your data has bad data in it. You have to be good about that. That's a schema migration, basically a schema migration. You have to be strict about the indices that you use. So regardless whether you're using NoSQL or using an SQL database, you still use indices. You still use B trees. You still have to look things up. And if you don't use an index, it will still do a collection scan. Now, if you do a collection scan on a NoSQL database, these data sets are huge, okay? So it is very, very important that you have an index on all your queries. So what we do is we created a Java annotation that's on every single query, and we make sure that the index is on every query. And if I don't see that annotation, that code's not getting checked in. So we look at that. We didn't, here's the big thing. We partitioned our databases wrong. So this was depressing. We had Percona come out, and Alex Rubin said, this is structured wrong, and so we need to restructure it, and we're still recovering from that. So I'm getting run out of time here, but I'll move on. We lacked isolation. We had other people sharing our database. This is also quite bad because if they ran a query and their query went out to lunch, it would affect our database. Bad idea. We're still covering that, trying to get them off our database. And we chose MongoDB support, so we went to Percona. So if you're going to use NoSQL, you might want to have Percona come in and do an analysis of your environment, what kind of sharding you need beforehand. Okay, so we started by ID. We made a UID and basically spread it across 4 different nodes. This is not very good because it does a scatter gather on every query. So you do a scatter gather, the Mongo S in the front reorders all the results, puts it, and sends them all back to you. That's not very efficient. So what we have is the nature of our data is that we have current data, the last year's worth of data, let's say, and all the old data nobody ever looks at. So the thing is what we want to do is we partition by the creation timestamp instead. So we put all the current data in one shard and all the older data in the other shard. So now all the indices are small for the year's worth of data, and it's large for the older data. And then if you do a query, most 90% of the queries are going to the last year's worth of data, and that one node can answer the whole query for you. It doesn't need to ask anybody else. There's no scatter gather going on. It basically just answers the query for you. And if you have a lot of reads going on, you create replicas. So this is the thing that Percona did that told us to do that we basically screwed up. So we're trying to recover from that by using Mongo 3.6, which just came out. And we tried to do a dump restore, but you're talking about a 12-hour downtime to get this dump restore working. We can't have a 12-hour downtime. So what we did was we made secondary copies of all of our nodes. And then what we did is we flipped a switch to do the sharding different. And what happens is MongoDB will actually go and move all the shards around overnight while you're sleeping, or for a week. And it'll give you the new sharding structure. So now we have 2 databases. We have one with the old sharding structure and one with the new sharding structure. We can flip the switch over to the new database. We can see how it performs. If it doesn't perform good, we switch it back to the old one. And we replicate both ways. So only with Mongo 3.6 were we actually allowed to do this in the new version. So we're trying to get to that, and this is what we're doing to solve that problem. So that's about it. I think I'm over time. Thank you. And if you have any questions about MongoDB or sharding, you can ask me, or better yet, ask Percona. And thank you very much.